Alright, so welcome to the video lecture series on Introduction to Computer Networks. Today's topic is going to be wireless LAN networks, or WLANs. So we have previously looked at the Ethernet LAN, and that is one of the most simplest form of network that you could set up for your local area network. This chapter is going to focus on the wireless version of the local area network, that is WLANs. As you can see here, the IEEE standard, the suffix is 802. That is same for both the version of LANs for Ethernet and wireless. However, for Ethernet LANs it's 802.3. For wireless LANs the standard is 802.11. The transmission type for wireless LANs are radio waves or radio signals, and the primary layers where they operate are the data link at the physical layer. We will look into it in details a bit later, but the wireless LAN technology allows collision avoidance while the packets are being transferred, so it is called CSMA/CA. CA stands for collision avoidance. The more commonly used name for wireless LANs is Wi-Fi, as most of you should have probably heard. The advantages of wireless LANs is the mobility of the nodes. That is, you can move around, you're not tied to a wire, and it relatively provides the networking feature with a lower cost compared to the cost of wires that you need to spend for Ethernet LANs. However, the disadvantages for wireless LANs still exist in terms of the security concerns, and you still need to have some form of wired connection to connect to the backbone of the larger network or the internet, and it requires a little bit more of technical skill to manage. So to look at a very simple wireless LAN setup, it looks something like this, where you have the internet, which is the larger network that is in the backbone, and then you have an Ethernet router which allows your wireless network to connect to the rest of the network. So the wireless network is facilitated through these base stations to which we as users can connect through wireless connections, right? And as you've probably seen across, for example, an office, a campus, or even at home, you may have more than one wireless routers or access points set up which are connected to the same backbone internet, and there are users connected to each of these access points. So we look at a few terminologies and concepts which are core in understanding wireless networks. So first of all, wireless hosts. So these are also called wireless nodes, and we are basically looking at the user or the terminal devices which are connected to the wireless network. So inherently, these devices should have the capability to connect over wireless links. They may be stationary. That means you may have a desktop which is connected to the network with a Wi-Fi dongle, or it could be a laptop where you may actually see yourself moving around, or a smartphone which allows you to move around within the range of the access point. And the examples of such wireless wireless nodes will include laptops, smartphones, wireless printers, which are the examples for maybe a stationary device. The next element for wireless LANs are the base stations. So as you can see here in the diagram, the base station is basically the central point which facilitates the wireless link connection to the wireless nodes, and also it's very common to see these wireless stations to be connected to the wired part of the network. So that means that you are essentially connecting to the internet through the base station. It's not only the wireless routers which could act as the base stations. The cell phone towers um, can also be base stations. You have the home access points. They are also referred to as base stations or commonly as access points. Next, we need to also understand the concept or the medium of connection for wireless LANs, and they are connected through what we call wireless links. So the wireless links are um, there to connect the wireless hosts, which are the nodes, to the base stations. They may also be used in the backbone link, but it's rather uncommon to use the wireless link to connect the backbone, that is the access point, to the internet, but it is still possible to do so. Um, and it requires a different variation of protocols in the data link layer to enable this connection. So there are many different protocols, and the other thing is it requires the multiple access protocol. That means it needs to facilitate the fact that a multiple of these user terminals are connected to the access point at the same time. So it needs to facilitate this particular feature. The wireless links, based on the different properties, they may have varying data rates and also the maximum capacity for the transmission distance. There are certain types of wireless links which do not have a long range. There are some versions which have a longer range. However, in most cases, the longer the range, the shorter or the smaller is the bandwidth. And one of the other things which is very closely related to wireless links is the concept of cell, which is nothing but the coverage area that could be reached with that particular technology. So every access point is associated with a cell, which is its own coverage area based on the particular technology for the wireless link. So when we are looking at wireless LANs, they have certain modes of operation. The most common type uh, or the most common mode of operation is what we call the infrastructure mode. And in this mode, it actually is exactly the same that we have looking at so far. They have base stations which are connected to the wired part of the network in the backbone. And then you have wireless nodes which are connected to these access points to form the overall infrastructure. The reason why we call it infrastructure is because any node which needs to be a part of the wireless network needs to first connect to the access point, and that is through which the overall connectivity to the remaining part of the network is provided. Another important thing that is required in the infrastructure mode, especially when you have multiple access points, is the concept of handoff, which means that when a node is actually moving from the coverage area, let's say from this cell to another cell, and this user 4 is connected to the red cell at the moment, and it needs to move to a distance which puts it out of range of this particular access point. It then needs to be connected to the other access point. And this overall protocol, where the user is disconnected from one access point and then reconnected to the other, this process is called handoff between the two access points. The next operating mode for wireless networks. We refer to it as ad hoc mode. This is slightly different than the infrastructure mode, given that in the ad hoc mode, there are no centralized entities. So you don't really have access points to facilitate the wireless network. And the nodes are connected to each other based on the range of their own network capacity. So these two wireless nodes can communicate with each other because they fall within the range of their own wireless links. Again, this is another cluster where each of these nodes can communicate with each other because they are within the range of each other. And as you can see, there are no centralized entities to facilitate the communication. And another thing is that in this ad hoc form, nodes actually can communicate through multiple hops. So let's say this wireless node needs to communicate with the other one, which is not in direct reachability of the first source. So what happens in the ad hoc mode is that it actually jumps across multiple other nodes to help the source and the destination communicate with each other. So instead of having dedicated routers or access points facilitate the communication, here the nodes are themselves providing as relays for the packets through the ad hoc network. So if you look at the overall concept of communication through hops, so in infrastructure mode, and if you're considering single hop, nodes are connected to the base station, which in turn connects to the internet. The most common examples for this would be Wi-Fi or cellular networks. However, if you consider multiple hops for infrastructure mode, we can say that in infrastructure mode, there are multiple hops when nodes are relaying through multiple wireless nodes, and then they connect to the backbone internet. So this is a slight variation or more of a complex variation of the infrastructure mode that we have seen earlier. On the other hand, in ad hoc mode, in single hop, we know that there are no base stations, so connection to the backbone internet may not actually be available. So one of the nodes, which is there in the ad hoc mode, may have connection to the backbone internet, and then the other nodes can actually use the node which is connected to the internet to access the rest of the network. Multiple hops in ad hoc mode is actually more common, and what happens is that nodes relay through other wireless nodes to reach the destination, which may not be directly reachable. Right? So for infrastructure mode, single hop is something which is more common. For ad hoc mode, multiple hops is more common for accessibility.